Hi everyone, welcome to Driven to Discover. I'm Andrea Lorick-Strauss with the University of Minnesota Extension, and in this video I'm going to give you a brief overview of the Driven to Discover project and give you a few pointers for using this program model and curriculum in your own setting. I'm going to tell you about what this project is, how it's structured, and a couple of the design elements I want to make sure you don't miss because these are the features that make it special. I also want to explain to you why we believe this program makes a great impact on youth and adult participants alike. We did some great research on the outcomes experienced by the participants in our pilot project, so I'll tell you about that. I'll have a few tips for how to implement the program, things we learned the hard way, and some instructions for how you can get started. All right, let's go. If you know anything about the University of Minnesota, you know that Driven to Discover is the marketing tagline for the entire university. We liked it for this project because it really captures that inspiration, that motivation, the drive to pursue science investigations. And that's what Driven to Discover is all about. It's a curriculum that outlines the design of a program aimed at middle school youth, age about 10 to 16. The general gist of the program is to have youth participate in citizen science and, through careful guidance by well-trained adults, to use that experience as a springboard into conducting full-blown science investigations of their own. The main goals of the program are to help youth develop science skills, to understand the nature of science and recognize the steps involved with doing science. And through this experience, youth grow in their sense of themselves as scientists, their sense that they can do science and that science applies to them. That's their science identity. And hey, did you notice we sometimes shorten Driven to Discover to D2D? It's a handy shorthand. Here's how we do it. The Driven to Discover program uses a three-step process. In the first step, youth build science skills. In this part, youth learn to identify the species they'll be studying in their citizen science work. They may learn to use binoculars and a field guide, or a magnifying glass, or to recognize look-alike species. In the second step, youth learn the protocols of a specific citizen science program. They learn to use data sheets and to enter data online to the citizen science program's website. They contribute to citizen science. Throughout these first two steps, youth ask questions based on what they are seeing and doing. These questions provide the fuel for moving into the third step. Using skills and experience gained in the first two steps, youth are now prepared to conduct a science investigation. They learn to take their random questions and convert them into testable questions. They compose hypotheses, make materials lists, collect data, analyze it, present it, the whole 9 yards. Whether D2D is implemented in schools or at nature centers or in Girl Scout troops, it's this three-step process that everyone does. Whether they do citizen science about birds, phenology, dragonflies, or whatever, it's this three-step process that makes it the Driven to Discover program. This is how D2D uses citizen science as a springboard into the full cycle of science practices. In this way, citizen science is a skill builder. It provides the experience on which to build the curiosity and confidence to drive youth through the investigation. One component of the program is designed for youth in out-of-school time programming. Places like nature centers, after-school programs, museums, 4-H, scouts, community education, summer camps, summer school, that sort of thing. When we pilot tested Driven to Discover with this audience, we used two existing, well-established citizen science programs. eBird from the Cornell Lab of Ornithology, which documents the distribution of bird populations, and the Monarch Larva Monitoring Project from the University of Minnesota, which looks at the distribution and abundance of monarch butterfly larvae. This version of the curriculum supports positive youth development with emphasis on creating a team learning environment, making community connections, and supports for adult leaders who may not have a lot of experience teaching about science. I want to emphasize, though, that the three-step process can be used with any other citizen science project. In fact, we've already seen it used with water quality projects, iNaturalist, and aquatic invasive species projects. How Driven to Discover plays out in these settings can vary widely. We see summer camps that meet for a couple hours a week for 10 weeks. We had some pilot test leaders do this in a compressed 5-day summer camp. You could do it every other Saturday or Tuesdays after school, whatever works. How it goes depends a lot on the club leader, the organization, the study sites available, the youth, and so on. For example, if you're going to do this in a community education after school program during the school year, you wouldn't choose to study monarchs because you won't find any. But as long as you follow that 3-step process, there's a lot of flexibility. We do recommend planning for at least 25 hours of contact time with youth participants, though. The other side of the program is intended for formal classroom settings. Typically, we've seen Driven to Discover implemented with 6th, 7th, and 8th grades, usually by life science or physical science teachers. These curriculum materials are a little different because the science classroom is a different situation compared to a youth program. In this series, the curriculum supports student practice at building scientific explanations. It includes exercises on data analysis, and it has a popular lesson called Science Behind the Scenes, in which the class analyzes primary scientific literature. There are also assessment suggestions and correlations to national science standards. These materials were piloted using a different array of citizen science projects. The National Phenology Network's Nature's Notebook, the Great Sunflower Project with a focus on pollinators, Odonata Central looking at dragonflies, and a reprise of eBird from the Cornell Lab of Ornithology. Again, there's a lot of flexibility on how D2D can fit into a classroom setting. It can be implemented in a couple weeks of consecutive class periods or spread across the school year. This depends on where it fits into the school schedule, but it should also reflect suitability for the citizen science project. For example, if your only time to do this is in winter, don't try to look for pollinators. Instead, you would choose the bird or dragonfly citizen science projects. The curriculum lays out several sample implementation plans, ranging from a light dose of just 4 class periods to a full implementation of 21 class periods. Okay, so that's the basic outline of what is involved with the Driven to Discover program. Now, let's take a quick look under the hood. I'll highlight a couple key features of the program design. This is the fun stuff. The whole point of the citizen science work is to help youth learn to slow down and observe nature. Sure, they learn and follow specific scientific protocols, but they also become really familiar with a study subject and a study site. They notice what's changing from day to day and take field notes as scientists do. All of this observing nature naturally sparks questions about what they're seeing. We have a structure for documenting the questions that come up. We call it the I wonder board. Maybe it's a bulletin board, but maybe it's an 11 by 17 sheet of paper with sticky notes. It's portable, everyone contributes, and it's evolving with new additions all the time. The curriculum also includes some helpful tools like worksheets for scaffolding the experience. These sort of training wheels provide structure for designing and tracking youth progress on their investigations. A tool that supports positive youth culture and development of science skills is the Scientist Roundtable. In this activity, youth present their research plans to each other one at a time. Youth can provide feedback and troubleshoot for each other, just how science colleagues interact. By doing this, sometimes multiple times, youth rehearse the process of thinking through an investigation. They develop a culture of thinking together to come up with the best plan, and they end up learning from multiple investigations, not just their own. We recommend that you arrange for some amateur or professional scientists to interact with the youth as much as possible during the Driven to Discover project. Maybe that means inviting your local Department of Natural Resources expert to talk to the class, or maybe it means you ask the local chapter of the Audubon Society to mentor the youth in learning to identify birds, or ask a graduate student to allow the youth to help out on their research work if appropriate. A scientist can help youth plan their investigations, like making sure they've phrased their research question properly or designed a data sheet well. They can also help youth organize data and draw appropriate conclusions. Most of all, scientists can be a great science role model. The curriculum provides suggestions for where to look for scientists who may be willing to work with your youth. Another feature we recommend is the opportunity for youth to showcase their work. This gives them the chance to show what they know and be experts. It also forces the wrap-up of the investigations. Deadlines are helpful. Of course, there's a lot more to the Driven to Discover curriculum, so be sure to look it over thoroughly. Now, I want to tell you about some of the evaluation we did to see whether this program design achieved the outcomes we were aiming for. During the pilot test with youth in non-formal settings, we measured a lot of qualities and attitudes in youth. While the program attracted kids who already had an interest in science, they still experienced statistically significant gains in knowledge related to science and citizen science. We also asked kids if they knew how to do things related to science and citizen science. Again, they reported statistically significant gains in these areas as well. What was more surprising was just how much the adult leaders benefited from leading these youth experiences. We asked the adult leaders what they knew about science, citizen science, and getting youth involved in science, both before and after their involvement in the program, and they showed statistically significant gains too. There's a full summative evaluation of this pilot test on the Driven to Discover website, so check that out for lots of details on this work. We're still conducting the pilot test of the classroom teachers and their students, but all indicators so far say that good outcomes are happening with that bunch too. Stay tuned for more formal results there. In tandem with the evaluation, we asked a research question during the pilot testing, which was, what factors provoke science inquiry thinking in youth? We found that a delicate balance is required between authenticity and engagement. By authenticity, I mean doing real-world science, using real science tools, asking real science questions that matter, and contributing to real, large-scale citizen science work. By engagement, I mean making sure that adults and youth are having fun, that they feel belongingness, and are genuinely interested in the work. There's a 6-page handout on the website that explains the factors that contribute to both authenticity and engagement, so check that out. And if you really want to know whether the youth participants developed a science identity, here's what happened when we asked them directly. When asked what makes you a scientist, look at what this girl said. She said, I question my world, and the data I collect gets submitted to and for scientific research. That's some authenticity and engagement right there. These girls said, I ask questions about everything, and I mean everything. And I am always asking questions and am willing to follow through on finding ways to answer them. Again, what more could we ask for? And this young man, I am a scientist because science is fun. Science makes you interactive with the world around you. It's better to see things in real life than just seeing it on a board or TV. Just think, would you rather sit down and experience nothing or go out and reach the boundaries of your brain? He gets it. Pretty impressive, huh? Are you ready to start using the Driven to Discover program in your organization or school? It's not hard to get started. First thing you should do is get your hands on the curriculum, which outlines the big picture of the whole program design and the details of what to do first, second, and third. Then you need to make some decisions. What youth will you work with? What time of year will this take place? What natural areas do you have to work with? Because that influences which citizen science project makes the most sense for you. I can help you think about what makes the most sense for your program and situation, so feel free to drop me a line. Contact info coming in a minute. But once you've made your basic decisions, then you can take a closer look at the accessibility of a study site for collecting citizen science data. You'll want to figure out how youth can have internet access during the program so they can upload their citizen science data. You may need to buy or borrow some equipment necessary to do the citizen science work, such as binoculars, field guides, dip nets, that sort of thing. And you may need some instructional materials like reference guides. Is there a way I can help you get started? This is part of my job, helping other organizations use the Driven to Discover materials, so don't be shy. All right, have I convinced you to go get the curriculum and give this a try? Right now, what you'll find on our website is the 2 sets of curriculum for the youth program non-formal settings. You'll find a facilitator's guide, that's the adult leader book, and an investigator's field journal, that's the youth workbook, for each of the 2 citizen science projects we field tested, birds and monarchs. These are ready now and you can download them today, and we hope you will. The curriculum for middle school classrooms is coming soon. They are in the final stages of production. There will be just 1 book each for the birds, pollinators, phenology, and dragonfly citizen science projects. No separate youth workbooks. There are copy masters for the student pages inside the teacher books. See, here's where you click on our website. All these resources are free. Anyone can use anything you find useful. When you go to download the PDFs, I'll ask you a couple questions so I can report back to my bosses, but I promise not to give away your contact info, and I won't contact you a lot, less than once a year, I promise. It just helps me to know how people are using the Driven to Discover materials. While you're on the website, have a look around. There are lots of great resources, including a bunch of great videos on our Citizen Science YouTube channel. And would you mind sharing it on social media like Facebook or Pinterest? That helps us out a lot. Okay, I hope this helps you get started doing citizen science with middle school aged youth. Let me know if I can help. You can email or call. My contact info is here on the screen or on the website. Hope to see you out there. Thanks.